So everyone can see the PPT, right? Without any interference.
Yes, sir.
Okay, okay, that's good. Okay, so yeah, like what I've already mentioned to you guys last week. So for 2 days, we're still going to talk about graph theory, but it will be much more deeper. It will be much more detailed in terms of what is the purpose? How can you make a full advantage of this theory, of this concept? Right. So I hope that you guys are still remember what are the basic properties of the graph, right? So it should be it have two elements. The first one is a vertex or vertices, a set of vertices, and also a set of edges or lines. So for examples like this one, like this picture. Okay, so yeah, just a little bit review. So can you help me to traverse this graph G below and find a walk or find a way from vertex U1 to vertex U number 4? So I hope that everyone still remember what is vertex, what is edge, and then how we can do the labeling of the vertex, what are the types of the graph. Right. So yeah, maybe someone can help me to just quickly help me to verify. So if you guys can find a work or a path or a route from this vertex U number 1 to vertex U number 4. Oh, right. Before I continue again, so the PPT for today's class, you can download it from the ULS. It's already been on already uploaded to ULS.
U1, F1, U2,
Right.
F7, U4.
Right. So this is one of the most straightforward way. Thank you, Kathleen. So one of the route would be from U1 to F1, and then U2 to F7, and then we get to U4 to the destination. So in here, U1 will be our starting vertex, the start vertex or initial vertex, and then U4 here, this U4 it will becomes the terminal vertex or the end point, the end node, right? So do you guys can you find any other route aside from the one that Kathleen has mentioned earlier, Gabriel or Kenneth?
U1, F1,
Right,
U2,
U2,
then F3 or F4,
FT or F4, okay, and U3,
U3,
right,
F5,
F5
and U4.
and U4, correct. Yeah, so this is also another route from U that leads from U1 to U4, U1, F1, U2, either F3 or F4, and then U3, F5, and U4. Thank you, Gabriel. So is this the only way that you can reach from U1 to U4? Is this like only these two ways that can lead you to U4? Is there any other ways that can help you to lead from U1 to U4, given this graph?
I think that's only 3 ways, sir.
Okay, so that's the only three ways. U1,
Like,
F1, U2, F7.
I mean for three.
Three, right?
Yeah, three.
Earlier, the first one, and then the second one is from U2, you took F3, and then go to F5, and then U4. And then from U2, you took F4, and then F5, and then U4, right? But actually, if we notice this, if you see what actually this graph is it a directed graph or undirected graph? So this picture here is actually an undirected graph, right? You cannot see the directions. There is no such thing as an arrow that pointing out the way that in which you should go in which direction for each of the line. So in that case, in that sense, so it's also possible for you to pick another route for examples. Okay, here U1 and then F1, U2, and then you go to F3, U3. It seems like the same like if you go U5, F5 and U4, right? But wait, from U3 here, you can go back to U2 through F4, F4 to U2, and then from U2, you go F7 to U4, right? So this is one another possible route that you can take from U1 to U4, or some other ways, U1, F1, U2, F3, U3, F4, U2, and then go back again F3, U3, F5, then U4. So actually there is a lot more possible ways, a lot more possible route that you can take to go from U1 to U4. So it's actually there is no such thing that limits your option. So it is based on what are the criteria on the questions that you are asked to. Here, the criteria here is you only need to find a walk, find a route, right? Find a way from vertex U number 1 to vertex U number 4. There's no limitations like how many steps that you need to take. So in that case, you can do like the loop here between U2 and U3 as many times as you would like to. Okay, so yeah, there are a lot of possible ways, right? So that being said, so there are several kind of special terms in this kind of a graph. So there are the so-called trails, paths, and circuits. In some of the reference later on, I will explain that some reference they will think that trails and paths they are the same, but they have like some other different terms. But mostly in general, so people will just say that there will be trails, paths, and circuits, and then there's some other kind of some other criteria that can create this kind of trails or paths or circuits. So let's see the definition here. So let G be a graph, and then let these two vertices, U and V, be a vertices in G. So a walk from U to V, a walk. So walk here is similar like from U1 to U2 here, you need to go through F1. So in that case, it will be U1, F1, U2. Here in this question, a walk from vertex U1 to U4, it means U1, F1, U2, you can go to F7, U4, or maybe it takes the other way. So this is only 3 possible solutions that I provide here, but actually you can expand the solutions to become a lot more, right? So here, okay, so this kind of walk from these two vertices must be a finite. So it should be countable, right? There should be some kind of a limit. It's a finite set of alternating sequence of adjacent vertices and edges of the so-called graph. In this case, graph G. Therefore, so usually a walk in a graph, it will have the form of like this one. For example, what is your initial vertex, initial nodes? For example, here, V number 0, and then the edge, like H1, V number 1, H number 2, V number 2, H number 3, V number 3, and so on until you reach H number n and V number n, right? With V represents the vertices and E represents all the edges. And then this V0 here is equivalent to vertex U here, and then Vn here is equivalent with vertex V. And for each I started from 0 until n. And then vertex at the sequence of I minus 1 and Vi usually the endpoints of its number I. So if you see here the pattern like it's number 1. So what are the endpoints for it number 1? P0 and P1. Of course, this kind of a sequence, it will be depend on how you label your graph, right? How you do the canonical labeling. So for example, like in these examples, we have like the edge F1, right? So the endpoints of edge F1 will be